Hey guys, okay, today we're gonna do Neat Code 150 again, and we're now at the part 5 of arrays and hashing, in which we do the next problem, top k frequent elements. Okay, I guess I can see that which one's the highest element. Given an integer, an integer k, return the k most frequent element. Ooh, so if k is equals 2, you need to find two most frequent elements within the array. So it goes two first and then three. It could be in any order. So it could start from three and then two. So it could be anything. Okay, okay. I think I can do this. I think I can do this. All right. All right. All right. But at the same time, I think I also can't. But still, I think I can do it. Okay. I think I can do it. Let's start timer. It's 10 minutes, and if I can solve that within 10 minutes, nah, nah, bro. I'm pro. We're gonna do 9:30. Okay. 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 So given an integer, okay, we already read that, no need to do it. All right, we're gonna initialize an empty list. Num cells already have a list, so we're gonna make a for loop for I, for num in nums. I guess we can also check a hash. Come on, shut again. No, we could do a brute force. Could do a brute force. And there's also a k, okay? For num in nums, we also need to like have a counter. So do we make a counter list or hmm, since we're gonna need to count it as well, and if we count that this one is the longest, then we're gonna output three. And since this is the second longest, we're gonna output two. And since the k equals one, we're gonna only output one that is the longest, and within seven and seven is only seven. Hmm, not quite sure, but that's fine. Let's think about it. So there's a variable. Oh, we can we need a notepad to try to maybe get an idea. So so you want to know what are the most frequent elements based on K from which are the most frequent elements. So yeah, I get it. So if this is three, then that means it's gonna output one, two, and three. If I'm correct, yeah, that's correct. And it could be in any order as long as it's gonna show the longest. In any order. So what's uh how, how do we do this? And when I'm gonna check the solution, I'm just gonna watch the video. I'm not gonna check the code. Yeah, I should check code. It's gonna I don't know. But yeah, that's still good. How do we do this? Possible. Possible. Possible how should we a hash map? Hash map counters do we even right now? Could could initialize an empty list. But wait, no, 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 no. Yeah, yeah, it should. Source. I found an empty list for nothing nodes. You could say hash sort was set. Yeah, that's still I mean that's progress, even though it might not be correct. For nomin nodes, we're gonna we're gonna put the num in the set. So num in nums. Yeah, I think we need the add function, but I forgot how to do the add function. So we could maybe look back at some previous solutions that we did, mainly in group anagrams. I'm pretty sure I made the hash set there. No, it's actually a default tick, and that's not it. Maybe in actually valid anagram. And no, it's not valid. I think it's two sum. No, it's not also. I did, I did, I did brute force. Contains duplicate. There we go, there we go, there we go. Okay, okay. We're gonna add, we're gonna, so send add the current number, and we're gonna maybe, so do you also make a counter though? I mean, counter this. Yeah, 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 that's an initial bound. Also try to shut that up. No. And this is confusing as hell. And I feel quite lost. Shut that up. No. So we put the num in the num now in the hash set now. And oh, what's next? So if num in the hash set, the stupid, the number is inside of the hash set. We should then we should then add it to a counter, right? But how? How do we count it? How do we like? I don't know the idea. So like we're gonna count it. I need a function that counts this. So now we put two in here, and then if two is already in the hash set, we should add a one to it. We can check the solution now, but no, we can ask. We can ask. Um, what line? What line? What? Ah, shh. Ah, you're gonna need this thing. You're gonna need this thing. Ah, I, I quite stuck on the problem. I mean, we put it in a hash or a map, but then it's oh, see, it's all you no not with what line. And we need a way to. However, there are a few things against your counting because you need a way to count. Can you think of a way to use a dictionary to count? How might you then use this dictionary? Oh, okay. So we need to create a dictionary. Is this an idea? Um, dic. Good. Now, how might you update this dictionary to count the occurrences of each number in nums? Uh, Um, and if okay, so not a hash set. What? Okay, okay, okay. We can now watch the video explanations. What the what the fuck is that? Frequency equals. Ah! This is the result. Wait, no! What? What the hell? I wouldn't guess. Well, what?
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve top k frequent elements. I really like this problem because it's pretty clever, and once you figure it out, the code is really easy to write. So we're given an input
Okay.
array nums and an integer k, and we want to return the k most frequent elements that appear in the array nums. We can return the answer in any order. So for example, we have this input array, 3 ones, 2 2s, and a single 3, and we want to return the two most frequent elements, right? So we know that the
Based on
most
K.
frequent is, of course, 1. It appears 3 times,
Yeah,
so
and
we
then
add a
2.
1 to the output. The second most frequent is 2, so then we add a 2 to the output, and that's all we want. Now, if k was 3, of course, we'd add the last element. K is never going to be greater than the distinct number of elements in the input array, so that's good for us. And our input array is always going to be non-empty. So for
Okay.
example, for each value, right, we're going to count how many occurrences it has. So for example, 1 occurs 3 times, 2 occurs twice, and 3 occurs once. And then we can take this, basically this list of pairs, right? Then we can sort it in ascending order, right? So basically it's already sorted in ascending order, right? Because the most frequent is here, the second most frequent is here, the third most frequent is here, right? Now, of course,
Okay.
sorting it in the worst case, right? Basically, if every single value in here was distinct and we wanted the top k distinct values, we'd get a time complexity of n log n, right? But we don't necessarily need to sort the entire thing because
Yeah.
we only want the top k frequent elements. So in another
Hash
solution, we could actually
map.
use a max heap. So we would still
What?
do this whole operation where we count the number of occurrences of
Maxi?
each
What
value, and then
frick
we'd
is that?
add each pair to our max heap. And the key of this max heap would, of course, be the number of occurrences, right? So the
What
count,
does
add each pair to our max heap. And the
max
key
heap?
of this
Okay,
max
a
heap would,
heap.
of course, be the number of occurrences, right? So the count, right? And then we'd pop from our heap exactly
Pop
k
from my heap.
times. So why is this more
Okay.
efficient? Well, we know popping from the heap. Well, first of all, when we initialize our heap, we're
Stack.
going to add this entire set, and
Yeah,
there's a
the heap
function
is
called
the data.
heapify, I think, that can do that in actually linear time, so big O of n times, so that's the good thing. And of course, we know we're only going to be popping from the heap k times. Each pop is going to take log n, and
Yeah, one.
we're going to
Yeah.
be doing that k times, right? So that's going to be k times log n, right? So that's a little bit better than n log n, at least as long as k is less than n, right? But it turns out that there's actually an even better solution. There's
Hash map.
actually a solution that can be done in O of n time, linear time. So big O of n time and big O of n memory. But we are still going to be using this exact technique where for each value, like 1, we count the number of occurrences like 3. So this problem can actually be solved in linear time if you use the algorithm called bucket sort.
Bucket
So when you
sort? Wait,
first think
that's
of bucket
bucket
sort, this is
sort?
probably what you're going to think of. The way bucket sort is usually taught is that for each value, for example, 1, we're going to take an input array, right? This is our input array. This row is the indices, the index of the array, and this is actually going to be the value. So for example, for 1, we're going to go to the index 1, and in the value, we're going to put, okay, 1 occurs exactly once. Now we're going to see a second one, we're going to say 1 occurs twice, right? Basically, we're going to go through the input array, count how many times each value occurs, and then in our input array, put that count for that index, right? Map the value to the index and then put the count of that value. So 1 occurs 3 times, 2 occurs twice, 100 in this case occurs once. Now this algorithm would be linear time if our input values, right, were bounded. For example, if we knew for a fact that every value was between 1 and 10, then we would know that the size of our input array is also going to be 10, right? But in this case, the values are unbounded, right? Like this could have been 1,000,000, and then the size of our input array would have been 1,000,000, even though the total input array size is only 6, right? We have 6 elements, but then that array where we actually store the bucket sort values is going to be unbounded, right? And also, we want the top k elements. This still isn't very clear of where exactly the top k elements are actually going to be. So in this case, this type of bucket sort doesn't work, but there's another way we can do it. So in this case, you can see for our array where we're going to be doing the bucket sort, the index, I was using each value in the input array. For example, 1 was being mapped to index 1, right? And there we were storing the count. There's actually another tricky way that you can do it that will lead us to a linear time solution. So if we're pretty clever, this is what we're going to do. For the index, we're actually going to be mapping the counts of each value. And in the values, we're actually going to have a list of which values have exactly this particular count. For example, 100, right? We know that 100 occurs 1 time. So what we're going to do is for this position 1, we're going to say, okay, this value occurs only once, 100. 100 occurs 1 single time. Which value, for another value in our input array 2, we see it occurs exactly twice, right? We can count that with a hash map pretty easily. And then we'll say, okay, this value occurs twice. So in the position 2, index position 2 of our array, we're going to add that value 2. 2 is the value that occurs twice. We see a last distinct value in our input array 1. We count it occurs exactly 3 times. So in this position, index 3, we're going to say, okay, there's a value, a single value, a 1 that occurs 3 times. Now it's possible maybe we had a third 3, right? Maybe 2 occurs 3 times. In that case, we would actually have multiple values in this position, right? But in this case, we can see 1 occurs 3 times, 2 occurs twice, 100 occurs once. So they're all going to go in separate positions. And then, once we've taken every single input value and counted how many times each value occurs and then put it in the appropriate spot in this array, what are we going to do? Well, we want the top k values, right? The values that occur, the top k values that occur most frequently, right? So what are we going to do? We're going to start at this end of the array. We want all the values that occur 6 times. Why are we stopping at 6 though? Why don't I extend this array farther, right? 7, 8, 100, right? Why do the indices stop at 6? Notice something about our input array. Our input array is size 6, right? So that means if every single value in the input array was the exact same, the most number of times a value could occur would be exactly 6 times. So the cool thing about this new array that we're creating is it's bounded by 6. Well, technically 6 plus 1 because we do have a 0, but that's not actually.
What the frick? So you create an array inside of an empty array in which the array is created for I and what? Okay.
Necessary, but it's basically it's proportionate to the size of the input array, right? So
we'll see.
Collaboration. So when we're scanning from right to left or however we do it, we're only going to be doing that. We can scan through the entire thing in linear time. Now in this case, we see 6. There's no values that occur 6 times, so we can't find our top k element in that position. We'll try the same thing with 5. 5, no values occur 5 times. 4, no values occur 4 times. 3, a single value. We're going to go through every value in this array, there's only a single value in this case, but we do see a 1 occurs. So to our result, we want the top k values, the top k occurring values, we are going to add a 1 to that. 1 occurs most frequently in the input array. So we add 1 to our result, we need 1 more. Because I think we were looking for the top
wait,
2 values. K in this
so
case
top
is going to
two,
be
so
2. So
find
now we're
one
going to
and
go here. Which values occur
gonna make the
twice?
count
A single
minus.
value, and that value is 2. So we're going to add that to our output array. So now we've gotten the top 2 values, and then we can return this array. Now, why is this linear time again? Because remember, the max size that this array could possibly be is going to be about equal to the size of the input array, right? Because we could have a value, for example, 1 could occur 6 times. In that case, we'd have 1 over here. Now, what if every single value in the input array was distinct, right? That's another extreme. What if we had 1, 2, 3, 4, 5, 6? In that case, this position would be empty because no values occur 6 times, no values occur 5 times, 4 times, 3 times, or 2 times. Every one of these 6 values would go in this position at index 1, reason being each one of these occurs exactly once. So in that case, we'll have all 6 values concentrated over here. And that's still going to be linear time because, yes, we are going to be iterating through this entire input array, which is going to be big O of n, and then we're going to add another big O of n to that, right? Big O of n plus big O of n, because we're going to have to iterate through 6 values in exactly one position. So that's still technically linear time. Now we are creating this array to help us, and we're also going to be needing a hash.
So, okay. So we're gonna create a frequency instead of an empty dict. Where do we make an empty dictionary? Yeah, there is counter, so yeah. Result should be in here. So interesting that is so bullshit. So frequency is equals to an empty list, in which that empty list has an empty list. Like what the hell? See? Which that, and then for I in range of nums plus 1. See? Yeah, we forgot the length because we can't get the unknown. Okay, let's keep going.
Hey everyone. 6 values would go in an array to help us, and we're also going to be needing a hash map to count the occurrences of each value in the input array, so the memory complexity is also going to be big O of n. With that being said, let's jump into the linear time code. It's pretty easy once you can identify this trick. So we are going to use a hash map to count the occurrences of each value. We're also the array, the special array that's going to be the same size as the input array about is going to be called frequency. Basically, you know, the index is going to be the frequency of an element or the count of an element, and the value is just going to be the list of values that occurred that particular many number of times. So I'm going to have an empty, I'm going to initialize this as an empty array. The number of empty arrays that go in this is going to be about the size of our input plus 1. So now I'm just going to go through every value in nums and just count how many times it occurs. So for count of this particular n value, we're going to do 1 plus.
So for n in nums, so this is mine, so this is wrong, but and we don't need an f. What? Okay, we don't need an f. It's so confusing. Oh. Yeah, no. Wow. Oh, so confusing. So we're gonna, for num and nums, we get the count of num. So the counter of num, in which is hey, you need to go now. Hey, it's my personal space now. Please, it's 8:22. Go na to your room. Hey. Please, I'm so bored. I'm busy doing something. Please. I'll be back. Please go now. Please, no. I just want space. Come on, it's almost night. I'm gonna sleep then soon. Come on, come on. Thank you. Next time, I'll let you. Just soon, I'm gonna sleep then soon, and I need personal space. Thank you. Oh, okay, okay. Oh, yes. So counter num, you add one, s- get num to 0, which is the current index. I can know that. Yeah, I know that. While copying this, I'm not gonna have much. I know. Count, count, and counter dot items, this is the items now inside of counter, the dictionary. We now append the most frequent of which we append the frequent count and append it to num. Yes. Uh, we apply the result, and for I in ring, this time, and in the length of the current frequency array minus 1, 0, 1. We can watch the video so we can at least understand what the
that
hell this
occurred
means.
that particular many number of times. So I'm going to have I'm going to initialize this as an empty array. The number of empty arrays that go in this is going to be about the size of our input plus 1. So now I'm just going to go through every value in nums and just count how many times it occurs. So for count of this particular n value, we're going to do 1 plus what its current count is, count.get n. Now if n doesn't already exist in our hash map or dictionary, we're just going to put a default value of 0. So this will return 0 if it doesn't exist. But this is how we're going to be counting the number of times each value in nums occurs. Next, we're going to be going through each value that we counted. So nc in count.items, because that's going to return the key value pair, every single key value pair that we added to our dictionary. And for every key value pair, for every number and count, I want to change in the frequency array, I want to insert. So for this particular count, remember the count is what's going to be the index. So at index count, we're going to append to that list this value n. What we're saying is this value n occurs exactly c number of times. And once we've done this, we've basically initialized everything we need to. So now we're going to have our result output, right? We want the top k elements. So
this shows the append the n, which is 1, and then it'll show how much time it's in which the c, which is like that, like you remember that I remember that bucket list. So that's the c is 1, 2, 3, 4, 5, 6 based on the length of the frequency. And if that's the amount of times the counted items is a number, and that's the counter, you append that
4.
number
And
to
so
the
we're going to be iterating through this array
to
frequency
the corresponding
in descending order, right?
counter.
Because we want to start with the
The
numbers that
frequency.
occur most frequently. So for I in range, length of frequency minus 1, which is the last index, and we're going to go
Okay.
all the way up until 0, and we're going to be going in descending order, so we're going to put a -1 as the decrementer. And we're
Okay,
going to
so
go
for
through every
wait,
value, so for every, let's say, n value, last index, and we're going to go all the
last
way up
index,
until
go all
0,
the
and
way
we're going
up
to be
until
going in
0,
descending order, so we're going
-1,
to put
so
a
you can
-1 as the
descend.
decrementer.
Oh,
And
I
we're
guess
going
this
to
is
go
probably an
through
object
every
on the
value,
side,
so
but
for every,
this
let's say, n value in
for I9 offline.
frequency at this index I, because we know everything
Or
inserted in
every
I
number
is actually
is
another
I.
sublist. So it could be empty or it could have some values,
Yeah.
whatever it does. So let's say n is non-empty. Then we're going to go ahead and take that n value and append it to our
That's
result because we're basically getting the n value that occurs most frequently.
Yeah, the
Now, when
most
are we going to
frequently.
stop?
But
At some
there's the
point, our
K
result output is going to be the exact
greater
same
than
size
K.
as k because we're guaranteed to have at least k values in our input array. So once that happens, if the length of result is matching exactly k, that's when we can go ahead and return result. We know this is guaranteed to execute at some point, so we don't have to put a return statement outside of the loop, and that is the entire code.
Oh my. Oh yeah. And there we go. This is a line 60. Oh, no. And okay, thank you for watching.